Hi everyone, I am JULKA. Today's topic is indefinite integral using by parts. In part 3, we already discussed question based on by parts. In part 15, we will discuss some more problem based on by parts. Example first. Integrate x into sine inverse x respect to x. Here we take sine inverse x as a first function and x as second function. So first function as it is, integration second x square by 2 minus derivative of first 1 upon the root of 1 minus x square into integration second is x square by 2. And now integrate second part. So first part remains same. In the second part, multiply and divide by minus. So we'll get x square by 2 sine inverse x plus half of minus x square dx divided by in the root of 1 minus x square. So now in numerator plus 1 and minus 1. And now divide second part into two portions, which is half 1 minus x square divided by in the root of 1 minus x square, which equals to root of 1 minus x square minus half dx divided by in the root of 1 minus x square. The formula of a square minus x square is x by 2 in the root of a square minus x square plus a square by 2 sine inverse x upon a. And the integration of dx divided by in the root of 1 minus x square is sine inverse x. After simplification, we will get x square by 2 sine inverse x plus x by 4 in the root of 1 minus x square plus 1 by 4 sine inverse x minus half sine inverse x plus c. Now when we further simplify last 2 points, 1 by 4 sine inverse x minus half sine inverse x, we will get minus 1 by 4 sine inverse x plus c. Or we can solve this question by other method. Whenever we in a question we have inverse, we can take that inverse equals to t. So now we put sine inverse x equals to t. So x equals to sine t. Now differentiate with respect to t both sides and we will get dx by dt equals to cos t. So the value of dx equals to cos t dt. Now replace x by sine t, sine inverse x by t, and the value of dx is cos t dt. The whole quotient divide by 2 and multiply by 2. And we will get t multiplied by 2 sine t cos t dt. The formula of 2 sine t cos t is sine 2t. Now we'll take t as a first function and sine 2t as a second function and solve by parts. First function as it is, integration second is minus cos 2t upon 2 minus derivative of first, integration second is minus cos 2t upon 2. Now the integration second part is sine 2t upon 2. And now we will simplify this whole quotient into sine. Minus 1 by 4 t, cos 2t is 1 minus 2 sine square t, 1 by 8, sine 2t is 2 sine t cos t, and the cos t is the root of 1 minus sine square t. Now replace t by sine inverse x and sine t by x, and the answer is minus 1 by 4 sine inverse x in bracket 1 minus 2x square plus 1 by 4 x in the root of 1 minus x square plus c. Or we can solve by another method. We take sine inverse x first function and x as second function. So first function as it is, integration second is x square by 2 minus derivative first 1 upon the root of 1 minus x square, and integration second is x square by 2. Now in the second part, we'll put x equal to sine theta. When we differentiate respect to theta, dx by theta is cos theta. So the value of dx is cos theta d theta. X square by 2 sine inverse x as it is minus x replaced by sine theta, and the value of dx is cos theta d theta. And after simplification, we will get x square by 2 sine inverse x minus half sine square theta, because cos theta cancelled by cos theta. Now when you want to integrate sine square theta, we will use formula 1 minus cos 2 theta by 2. So minus is outside, 1 minus cos 2 theta by 2 respect to theta. Now take, in the second part, take 1 by 2 common. So we have minus 1 by 4, integration of 1 is theta, and the integration of cos 2 theta is sine 2 theta by 2 plus c. Now replace theta by sine inverse x, and sine theta is 2 sine theta cos theta, and the cos is the root of 1 minus sine square theta, and replace sine theta by x, and the answer is x square by 2 sine inverse x minus 1 by 4 sine inverse x plus 1 by 4 x in the root of 1 minus x square plus c. Next example. Integrate sine inverse x whole square with respect to x. Whenever we have a question of log or inverse, we will take 1 as second function. So sine inverse x square is a first function and 1 as second function, and now we'll solve by parts. First function as it is, integration second is x, minus derivative of first is 2 sine inverse x into 1 upon the root of 1 minus x square, and the integration second is x. Now in the second part, we'll put sine inverse x equals to t. So the value of x is sine t. When we differentiate with respect to t both sides, we will get dx by dt equals to cos t. So the value of dx is cos t dt. In the second part, replace x by sine t, sine inverse x by t, and dx by cos t dt. And after simplification, we will get x sine inverse x whole square minus 2t sine t, and the cos t cancelled by cos t. Now we will integrate t sine t using by parts. We will take t as first function and sine t as second function. First function as this, integration second is minus cos t, minus derivative first, integration second is minus cos t. Now integration of cos t is sine t, and when we simplify this, we will get x sine inverse x whole square plus 2t cos t minus 2 sine t plus c. Cos t is in the root of 1 minus sine square t. Replace sine t by x and t by sine inverse x, and the answer is x sine inverse x whole square plus 2 sine inverse x in the root of 1 minus x square minus 2x plus c. Next example. Integrate x tan inverse x with respect to x. Here we'll take tan inverse x as a first function and x as second function and solve by parts. First function as it is, integration second is x square by 2 minus derivative of first is 1 upon 1 plus x square, and the integration second is x square by 2. In the second part, we will take 1 by 2 common. Since the power of numerator equals to power of denominator, so we will divide the fraction and solve. And we will get 1 minus 1 upon 1 plus x square. Now when we integrate this, we will get x square by 2 tan inverse x minus half in bracket x minus tan inverse x. Or after simplification, we get x square by 2 tan inverse x minus half of x plus half of tan inverse x plus c. Or take tan inverse x equals to t. X equals to tan t, and the derivative with respect to t is dx equals to sec square t dt. Now replace x by tan t, tan inverse x by t, and dx by sec square t dt. Now we will take t as a first function and tan t into sec square t as a second function. When we integrate this, we say t as it is, integration second is tan square t upon 2. Minus derivative first is 1 and integration second is tan square t upon 2. And now integrate the second part. Whenever we have tan square t, we will replace with the formula sec square t minus 1. Integration of sec square t is tan t, and the integration of 1 is t. Now replace tan t by x and x by tan inverse t. So we have the answer x square tan inverse x upon 2 minus half in bracket x minus tan inverse x plus c. Integrate sine inverse 2x divided by 1 plus x square with respect to x. This equals to 2 tan inverse x. Now either we have a question cos inverse 1 minus x square upon 1 plus x square with respect to x, or we have a question of tan inverse 2x divided by 1 minus x square. The formula of all three is 2 tan inverse x. Now we'll take tan inverse x as a first function and 1 as second function and solve by parts. First function as it is, integration second is x minus derivative first is 1 upon 1 plus x square, and the integration second is x dx. In the second part, we divide by 2 and multiply by 2, and the answer is 2x tan inverse x minus half cancelled by 2 and log 1 plus x square plus c. Next example. Sine inverse 1 minus x square upon 1 plus x square with respect to x. the formula of sine inverse x plus cos inverse x is pi by 2. So sine inverse is pi by 2 minus cos inverse 1 x square upon 1 plus x square. And the formula of cos inverse 1 x square upon 1 plus x square is 2 tan inverse x. And now we solve with the help of the above example. The answer is pi x by 2 minus 2x tan inverse x plus log in mod 1 plus x square plus c. Whenever in bracket we have function plus derivative of that and the whole multiplied by e raised to power x. And when we integrate this, we'll get the answer function multiplied by e raised to power x plus c. For example, if we have a question, integrate sin x plus cos x in bracket multiply by e raised to power x, integrate respect to x. So we'll first divide this question into two parts, sin x into e raised to power x dx plus integration of cos x into e raised to power x dx. Derivative sin is cos, so we'll solve first part. First function as it is, integration second minus derivative first is cos x, integration second is ex, plus integration of cos x ex respect to x as it is. So cos x ex cancelled by cos x ex, and the answer is sin x into e raised to power x plus c. Next example, we have a question log x plus 1 by x multiplied by e raised to power x. First we divide this question into two parts, log x into e raised to power x respect to x, integration 1 by x into e raised to power x respect to x. Solve the first part, log x as it is, e raised to power x, integration is e raised to power x minus derivative first is 1 by x and the integration second is e raised to power x. So 1 upon x e raised to power x cancelled by 1 by x e raised to power x. So the answer is log x into e raised to power x plus. Next example, integration of e raised to power x multiplied by 1 plus sin x divided by 1 plus cos x respect to x. Whenever we have sin x, the formula of sin x is 2 sin x by 2 cos x by 2. And formula of 1 plus cos x is 2 cos square x by 2. Now we divide this question into two parts. So the first part will get 1 by 2 outside, sec square x by 2 into e raised to power x, plus in the second part, integration of tan x by 2 into e raised to power x. Derivative of tan x is sec square x. So we'll solve the second part. So first part remains same. In the second part, tan x by 2 as it is, integration of e to the power x is e to the power x minus derivative first is sec square x by 2 into 1 by 2 into integration second is e raised to power x. After simplification, we'll get the answer tan x by 2 into e raised to power x plus c. Next example, x square plus 1 divided by x plus 1 whole square into e raised to power x. Now in numerator we add 2x and subtract 2x, and after simplification we'll get answer x plus 1 whole square divided by x plus 1 whole square into e raised to power x minus twice of x divided by x plus 1 whole square e raised to power x. The integration of first part is e raised to power x. In the second part, we will add and subtract 1 in the numerator. And when we simplify this, we'll get the answer e raised to power x minus twice of e raised to power x divided by x plus 1 plus c, because derivative of 1 upon x plus 1 is minus 1 upon x plus 1 whole square. Next example, integration of log x plus 1 upon log x whole square with respect to x. Always remember that whenever in a question we have log, put log x equals to t. So when we put log x equals to t, x equals to e raised to power t. Differentiate respect to t both sides, so we'll get dx by dt equals to e raised to power t. So the value of dx is e raised to power t dt. Replace log x by t and dx by e raised to power t dt. And now divide this question into two parts, log t into e raised to power t dt plus integration of 1 by t square e raised to power t dt. Now we solve the first part. First function as it is, integration second is e raised to power t minus derivative first is 1 by t, integration second is e raised to power t dt. Now we will solve 1 by t into e raised to power t, taking 1 by t as a first function and e raised to power t as a second function. So 1 by t as it is, e raised to power t is e raised to power t minus derivative first minus 1 upon t square into integration second is e raised to power t dt. When we open this bracket, we'll get log t into e raised to power t minus 1 by t into e raised to power t minus 1 by t square e raised to power t dt plus 1 by t square e raised to power t dt. And after simplification, we'll get answer log t minus 1 by t multiplied by e raised to power t plus c. Replace t by log x and e to power t by x. So the answer is log x minus 1 upon log x whole multiplied by x plus c. Next example. Integrate 1 minus x whole square into e raised to power x divided by 1 plus x square whole square with respect to x. First we simplify the numerator and we'll get 1 plus x square minus 2x whole divided by 1 plus x square whole square and the whole multiplied by e raised to power x dx. Now we'll divide this question into two parts and we will get 1 upon 1 plus x square into e raised to power x dx minus 2x into e raised to power x divided by 1 plus x square whole square. Now we'll solve the first part. In the first part we'll take 1 upon 1 plus x square as the first function and e raised to power x as second function. So first function as it is, integration second, minus derivative first is 2x divided by 1 plus x square whole square and minus outside, and integration second is e raised to power x. After simplification, we will get the answer e raised to power x divided by 1 plus x square plus c. Last example, x square ex divided by x plus 2 whole square. Now in the numerator we will add 4x plus 4 and subtract 4x plus 4 and the whole multiplied by e raised to power x divided by x plus 2 whole square. The first part is x plus 2 whole square divided by x plus 2 whole square multiplied by e raised to power x. So the answer is only e raised to power x. And the second part minus, take 4 common, x plus 1 divided by x plus 2 whole square multiplied by e raised to power x dx. Integration of e raised to power x is e raised to power x. In the second part, we will add 1 and subtract 1. And after further simplification, we will get e raised to power x minus 4 times of 1 upon x plus 2 e raised to power x minus 1 divided by x plus 2 whole square into e raised to power x dx. The derivative of 1 upon x plus 2 is minus 1 upon x plus 2 whole square. And we'll get answer e raised to power x minus 4 into e raised to power x divided by x plus 2 plus c, and after further simplification we'll get e raised to power x multiplied by x minus 2 divided by x plus 2 plus c.